chromosome synapses and crossing over, which is part 2 of the options. Here we have set 1, which is 2 chromosomes, MLI, centromere JKHG, and chromosome 2, GHI, centromere JKLM. Not much similarities between them, kind of confusing at first, but I see that the starting and the ending is the opposite for each, so I'm going to flip them around and see if that helps. So I flip them around, and you get ML for the first 2 on each, and HG for the last 2 on each, which means the middle 3 is the only difference. So that is very helpful. So here you can see I set them up side by side. You have IJK and KJI with the centromere between I and J on each, and that helps explain something to me. That shows me that there's a paracentric inversion happening. Flipping of a segment inside of a chromosome is the only difference between these 2 chromosomes. So as you can see there, that's completely true. Here's a very confusing chart happening, but I could show y'all what is happening. So the first one is just the parent cell, essentially. So MLI, centromere J, K, HG, no crossing over, right? And the third one is also essentially just the other parent. So you have ML, K, J, centromere I, HG, okay? What's the difference is the crossing over, which happens in 2 and 4. So for 2, you're gonna go MLI, centromere J, cross over into K, and then back to L and M, okay? And then for 4, you're gonna go GHI, centromere J, crossover K, and then back to H and G. Okay, so here are the 4 results, which I just explained. The first one's not viable because there's a M and an L, there's 2 sets of those, and there's no H or G on it, so there's not all the parts you need for a chromosome. Second one's viable, it has all the parts it needed for a chromosome. Third one, not viable, 2 sets of GH, no sets of MLs. And the final one is also viable because it's got all the parts to a chromosome in it. For set 2, we were given MLI, centromere JKHG for the first, and for the second, we have GHKJ, centromere ILM. Okay, I reversed those 2 because M and M were there and G and G were there, but they were on the wrong sides. So when you reverse them, you see that they are the exact same chromosome because there's no left or right to a chromosome. No aberration. Chromosomes are the same because there's no left or right to the chromosome. So crossing over, as you can see here, fairly basic, okay? I'll explain it, but really nothing's happening, okay? For the first and the fourth one, they're the exact same. Crossing over occurs in the second and third, but because they're crossing over with essentially the same chromosome, you're going to get the same final results. So here are the results, MLI, JK, HG for all of them, okay? All are viable because all are the same. Finally, which one is more set for fitness? So set 2 versus set 1 for fitness. Set 2 is twice as fit to survive because the 2 parent chromosomes produce 4 viable solutions because they were the same, while set 1 only produced 2 viable solutions